What's up, YouTubers? So for today, I got a little bit of a challenge video, and not so much, I guess, for you guys, although you can definitely partake in what we're doing here, but for me, and I'll explain. I had a viewer request. He said he was trying to make a 90-degree welder's square out of 1/8 inch, 1.5 inch angle iron, okay? Now, I don't know if he was trying to get a 90-degree inside corner or a 90-degree outside corner. I have no idea, so we'll come up with something. But his issue was, well, one, he couldn't cut straight. So he was hoping, down the road to get a dry cut saw. And, well, I got news for you. You don't need one of those to make straight cuts, and I'll show you a couple ways on that, how to do that. So that was an issue. And two, he found out the hard way that when you take something and you put heat to it with welding, that it doesn't stay straight. Now, he believed that maybe he didn't have it clamped hard enough, but I can tell you that there's far more to that than what you would think on keeping stuff straight. So what we're going to really tackle today is we're going to make a welder's square of some sort that's hopefully going to be perfectly 90 degrees. And I'll show you a ton of ways to do that. And we're going to talk all about how metal warps and what you can do about it when welding, all sorts of stuff. So this is going to be kind of a little bit of fabrication and also a ton of tips that will hopefully help you on projects other than this. So let's get into it. So if you want to make anything that's reasonably high precision, aka square, straight, plumb, true, level, whatever, you have to start out with some form of an instrument that's accurate to test that, which in the case of this square here should hopefully be accurate enough to make another square of some sort. But, if you're trying to make something accurate, having a precision instrument tell you whether or not it is kind of a must. And I want to show you something. So this, in theory, is a perfect 90-degree angle. Is it perfect? Well, who knows? This thing has been around the shop, fallen on the floor a few times. We don't know that, but I would take a guess and say it's probably more accurate than a lot of things. In front of us, we have a piece of very thick, 3/8 thick angle iron. And the reason I bring this up is that it's very common for myself and other people to use this as a base to clamp to get a 90-degree angle. And I will show you what I'm talking about. So what you can see there is this is fairly accurate, okay, to a 90-degree outside corner, but it is not perfectly accurate. Now, for a lot of the things we do, the accuracy of this outside corner is more than close enough to meet what we're looking at doing. However, if you absolutely have to have precision, guess what? This isn't going to cut it. Not only that, if you look at the surface finish on this with all this mill scale, and then this is ground clean, the accuracy is probably plus or minus 1 or 2 degrees on this end to end, depending on where you clamp it. Now, if you were to take and machine this thing flat, you could definitely turn it into a higher precision instrument of sorts. But again, we're just basing on what we have here. Out of curiosity, I'm going to look at this angle iron and see how close this is. If I can get it on. I haven't looked at this yet. So it's close, but it's got a little bit in it. Here, I'll bring that down. I can rock this ever so slightly on it. So again, 1 or 2 degree accuracy. So knowing where you are to start with really helps. So we already know that from a 90-degree perspective on this, we're a little bit off. But that's all right because that's of little concern. We mainly want an outside corner to be 90 degree or an inside corner, depending on what type of square we're making. So now let's look at a couple ways to cut straight. So the first way to make a 45-degree angle on something like this so that we can, with 2 cuts equal 90, is to take your square here, make sure that the ruler's locked down so it's accurate. Hold it on your steel and then simply mark it. That is as close to a 45-degree line as you're going to get. Now, by taking an angle grinder with a cutoff disc, we can actually cut through this, and as long as you follow the line, which on a short cut like this really isn't that hard, it's not going to be that difficult to get a perfectly 45-degree miter. Now, to do this other side, what you got to do is just line this up with where that terminates on this. You'll have to bear with me a little bit because I got to balance a lot of things here. All right, somewhere about right there. That looks pretty good. So as long as we angle grind on those marks and grind straight to cut through that, we will be looking good. So that's what I'm going to do now. I'm going to clamp this down to the table hanging off, cut it off, and then we're going to use our square and look at how accurate this is. I'm not sure what happened, but the footage got deleted by accident or something with me cutting off that angled piece. It's pretty easy with an angle grinder. Just be smart about it. Don't cut your fingers. All right, let's move on to some alternative methods. So another way you could expedite this is to take your square, a piece of steel like this, square it up as good as you can to this material, and then you would take another piece, slip it under here, line it up with approximately, in line there, so this edge is in line on this bottom plate to here, weld it underneath here, and now you have essentially what is a makeshift square for getting 45-degree angles on this very accurately fast. Now you can see this, we can get a very fast and accurate 45, but then we have to switch and go down here and then mark it that way. Well, if you made a little jig here that was set up just like I'm showing you here, you would be able to slide it on, hold it, and then mark both of them in like 1-2 seconds, and you're exactly on. So that's another option just for making marks faster. The other thing you can do, let me take this off, is if this was set up like this, you could actually just clamp it where you want it and then use this without even marking it with a marker, use that as your cutting guide. Now, over time, this will wear back, so the accuracy in the long term may not be the best, but by leaving that set up and then taking your angle grinder and then running it right down that edge and using the edge as a straight guide, essentially, straight edge, you will be able to cut, 6-7 of these pretty fast and have very accurate cuts. The other thing you can do with it as well, and this is a better application for this, is to use, one of these Diablo carbide blades and a Sawzall, and with this clamped down tight, you could just run it and chew through it all the way down and have pretty much a 45-degree cut very fast. I mean, this is by far faster if you set up a jig and just super clamped it nice and tight and then use a saw to cut it. You would get very close to 45-degree miters without any trouble. And that's something, I own a dry cut saw, and honestly, getting 45-degree miters on that is a little bit harder than you might think. And yeah, it's fast. I mean, yeah, I can rip through this in a matter of a few seconds without even, marking anything. But I find that the dry cut saws on thicker steel, I mean, not so much maybe this 1/8 inch, but on thicker steel, it has a tendency to wobble and walk a little bit, not to mention the miter boxes on those things are so far from accurate that if you really have to get a 45-degree cut honestly, you have to set up every cut and verify it's at 45, because mine has a cast aluminum base, but the little indexer to do miter cuts is plus or minus probably 4 degrees. So long story short, like this is simplistic as setting a jig up may actually be more accurate than a dry cut saw. It's slower, which we all know that taking a long time to do simple things like cuts is not really in your best interest. But like I said, this is to teach you guys some solid ways of doing this accurately with minimal tools. So with that in your head, a little better idea of what to do with this, let's talk a little bit about warping and how to control it and how to make things not warp in a direction you don't want to. So keep things straight. Let's get into it. All right, so I angle grinder cut one of these. The other one I actually use that Diablo blade on the Sawzall and just cut it, and both of them seem to have came out pretty accurately. So no real difference there. Now our square, with this set exactly where it needs to be, very minimal, like I can't rock it much. So this is looking pretty good, and our gap very tight all the way over. It goes without saying that if you want to control bending and warping after welding, the tighter the gap that you have, the better. You know, it's going to be very difficult if you have like a 1/4 inch gap down here to not have this collapse on you for an inside corner. As that weld solidifies, it's going to pull, it's going to shrink. So to weld this, I would say that our best bet is to actually have a little bit, and I'll move this out a little bit of a gap here, so it's a little bit more open than 90 degrees by a degree or two. I'm going to put a tack up here, a tack on the edge right here, and then I'm going to put a tack probably on the underside on the inside of that corner. And I'm going to look at everything after I do that and check where it is. With that kind of better in mind, we'll be able to go from there. One of the things you guys want to get in the habit of is anytime before you start welding on something, like this is the first welds I'm going to do for today and the machine was just turned on, you want to make sure that everything's working. So rather than me just going and tacking that and finding out, oh, I didn't turn the gas on if I was MIG welding, or oh man, my settings are way off. Take a piece of scrap the same thickness as what you're welding on and run a bead, just so you know it's running good. So based on that, which I use settings that they recommended, which is 17 volts and 210, for wire feed, we have a little bit of burn through at the start and the stop. I would say that that's plenty on the hot side, probably almost a little bit too hot, but I think for tacking purposes it will work. So I'm going to put a tack right here, and then I'm going to go on the inside and tack the edges together. All right. So we have that all tacked up. I'll show you. Let's take a look and see how much, if any, that this actually pulled out a square. So I can rock this a little bit, which means that it pulled a little bit out of square open. Now we got a couple options that we can use to deal with this. If I weld the back side of this on the inside first, it probably will shrink and tighten this. Now being that this is an inside corner square, if I weld it in here, we may not be able to use this as a square, if you know what I'm saying. Like we would have to grind the weld out. So what we're going to try and do is weld the inside start to finish and see what happens. Now I am going to lower my values a little bit. So I'm going to go from 17 and 210 for wire speed down to, we'll take a guess and say 16.4 and 190. Just a rough guess. This is 035 flux core wire. Definitely a little bit on the hot side, so I did some spot welds there. Being that this is an outside edge, I don't know that I'm going to be able to run a continuous bead on this unless I run really low values, because it's so thin on there. So I'm going to just spot weld it up. I don't generally like doing spot welds, but for the sake of what we're doing here, we want to reduce as much heat input as possible and try and avoid potential issues, so I think it'll work. All right, so we got that. Let me move it to where you can see it. We got that spot welded up. Again, I rather run a continuous bead, but being that that edge is so thin, I don't know that we're gonna be able to do that. And certainly this early in the day, I'd need at least a couple coffees in me and some practice to really get that dialed in. So you can see our weld is actually decent looking, very little spatter. This Hobart Fab Shield is really good. I'm impressed. Now if we look inside, very minimal melt through, and that's what we're kind of hoping for. We want to keep that inside corner as straight as we can, as straight 90. That way we can slip this on something with a sharp edge and it won't, it'll sit in there. All right, let me brush this a little bit and let's check the accuracy. So let's take a look at how accurate we are. And we're a little bit off. Here, I'll move this to where you can actually see it. There you go. Ever so slightly, we're off a 90. Now, let me make sure I'm holding this. Yeah, you can see there's about, I don't know, a 32nd of an inch. I mean, it's not much, but it is off. So the question is, well, how do we fix this? Now, there's a number of ways that we can fix this. Now, first off, had we clamped this to a piece of angle iron, like this, and had clamped it here and here, welding that on the inside may have caused it to pull less. However, my guess is that the tension in that weld's trying to shrink would have still, as soon as we unclamped it, still would have pulled it this much. So clamping it to something sturdy may or may not work. Another thought is rather than cutting these exactly at 45 degrees, doping it with 1 degree or 2 degree to where it was tighter, that would have helped, because when we welded the inside, it would have pulled it essentially straight. Now, to fix this predicament that we're in, we can do any number of things. We could technically take an angle grinder, cut this and cut this tack, tap it a little bit, weld this, and by cut this in here, I don't mean cut the whole weld, just give it a channel for it to bend this way, and cut this tack, and a couple little light blows of a hammer will tighten it up a little bit, and then we can weld it starting right here, run a couple tacks, let it cool, couple tacks, let it cool, couple tacks, and we're done. So that's a possibility as well. Will that work? It may. Another option we have is to heat the inside of this with a torch after cutting a little bit of a relief in there, and it will, as it cools, that red hot metal will shrink a little bit in here. That will bring this forward as well, so that's an option. Another option we have is to cut this tack, bend this forward a little bit with maybe 1 or 2 degrees extra, re-tack it, and then weld it down. The problem is that the wider this gap in here gets, the more it's going to want to shrink and pull down and bring everything out of alignment. So those are just a few ways. We could also even clamp this down to this bar and just try and weld this and put, I don't know, another weld on the backside to get enough heat, and it may, with a little bit of a, you know, clamping pressure this way, it may pull it straight. Hard to say. But I'm going to decide which one we're going to do, and then we're going to attempt it and then see the results. Oh, and I almost forgot. We could, and this would likely fix it, just weld it straight in here, let it cool, and then just grind that weld out of there, you know, to where it's flat. And I think, honestly, that's probably what we're going to try and do. All right, so I made a decision. I'm going to run a small weld on the inside of that. I increased my voltage a little bit to 16.6, and I lowered the wire feed to 180. Now, I'm using 035 flux core. This would be a better job for 030 because you could deposit a lot smaller of a weld, I think. But I'm going to run a nice, you know, high voltage, or, well, comparatively for the wire feed, try and get a nice flat weld in there, and then we're going to look at it. So I went over to get a sip of coffee and heard a pop, and guess what? Mistakes were made. This bottom tack broke because this shrunk so much, it pulled it over, and look, that's how much that weld pulled it out of alignment. But we're actually still in okay shape. What I'm going to do is grind this out a little bit so that I can squeeze this a little bit closer to straight. We're going to re-tack it, and then we're going to recheck it. All right, so I ended up running a pretty hot tack over here, kind of blew the end out a little bit. That's all right. We're going to grind that round anyways. But I thought I would show you. All right. There's basically no movement at all in this, and there's no gap at all, so it's almost, so it tipped slightly this much, 1/4 of a degree. So we're in good shape. What I actually did is I positioned this slightly that way, and then when I tacked it, it took about 20 seconds, it pulled straight. So by doping it a little bit too much that way and assuming the weld metal is going to shrink and pull, I was able to get it pretty close to in line, and it's, as you can see, there's a whisper of a gap down there, and that's exactly what we want, because when we weld this out, it's going to shrink a little bit and it's going to pull that straighter. So my thought is, we're close enough to the finish line here. I'm going to take and actually weld the inside, and I'm going to do spot welds. And the reason is that when I weld it and it solidifies, cools down, it's going to become solid. And then as I do another spot weld, it's going to have a harder time pulling because there's solid metal there. When you do one continuous hot bead, what's going to end up happening, just like an auto body, is it's going to pull tremendously because you now have that whole length of weld that's shrinking at the same time. By doing little bits at a time that are going to shrink, it's going to warp less and it's going to pull less. So my hope is that I'm going to clamp this down to the table here on this, and I'm going to sand it a little bit smoother, clamp it down, and then weld the backside, and we'll see where we're at, how much it pulls. So to show you, our gap is completely the same, bottom to top there. So we are officially square. Now, I welded this side with just a series of tacks, not the prettiest thing. I'm going to clamp it down and weld a series of tacks here. It's not going to shrink that much. And we'll finish that out, we'll grind this smooth, and then I'll take a grinder and clean this out a little bit to where we can have like a straight 90. Shouldn't be too difficult to do that. And then we'll go and look at it with the square in a bunch of different directions and see how close it is to actually being a square. So I buffed it all up, cleaned it up, cleaned some of the mill scale off. As you can see, that's about as good as you're gonna get short of machining something like this, which, I mean, most squares that you're gonna find are all machined square. They're not like welded from 2 pieces of angle iron and then not machined. It's just the time it takes to square everything up, it's far easier just to machine it. But I'll put it back here. I relief cut down in the throat of that a little bit to give some clearance, but I mean, this is very, very close. There's like no wiggle room in it at all. I mean, I can't even wiggle it. So better than I guess I would have expected for this. You could see it was quite interesting trying to get this to come out. And I made a bunch of mistakes during the process, which is kind of the point of trying this. You know, it's not like I build squares down here in the basement all of the time. So it was a learning process for me. So let's go and go to the conclusion. So in conclusion, what did we learn today? Well, I learned that you can do a lot and to pretty high accuracy with very minimal tools. Take a look at this, just rubbing there. I don't know, better than I would have thought that I could have done given the circumstances. But we learned a lot about how metal warps, and this affects all welding, not just, you know, making squares. Let's be honest, a lot of us aren't going to do this. It's far cheaper, easier to just buy a square. But hey, can you do it? Absolutely. Will it work? Yeah, I mean, it does. But, you know, there's a lot of pitfalls you can find yourself in, one of which I almost found myself in, and that's you end up chasing your accuracy around. So it's bent one way, so then you weld it or modify it to bend it the other way, and then you go too far and you end up chasing, you know, your numbers around, and you can't get it dead on. And to get things dead on really require experience in knowing what's going to happen, and you simply don't know what will happen unless you have experience. I fortunately have enough to kind of know what kind of pitfall I'm getting myself into with this, and I was mildly successful. But the whole point of this is really to show you that with a little bit of pre-planning and thought process in something, you can actually have pretty high success. I also want to mention on this, and I had said I don't commonly tack weld with flux core, and if you look at here, you can see pin dot porosity in there after I ground the weld down. That's going to be very common with flux core, and I even brushed all the slag and flux off of the weld before, you know, I'd tack it, clean it, tack it, and I still have that. Now, part of it is I welded on a side after the other side was welded, and it brought likely some contaminants through, but even so, very common with flux core. In order to prevent this, I would have had to have ran a lot higher of values, and those higher values may have caused enough heat input to warp this. So when doing tacks, like I had said in a video, I'm not a huge fan of doing tack welds with flux core wire. That's a better job for TIG or MIG, processes that don't have flux or slag inclusions, etc. You get the idea. But beyond that, I think it's important to practice stuff like this. I mean, maybe not making a square, but pushing a limit on what you can do, just so you get an idea of what's going to happen. And I know when I was growing up and learning to fix stuff, like I made countless mistakes and just stupid decisions. I mean, even on my Jeep the other day, I ended up wrecking a $200 and some clock spring because I pulled a steering wheel and wasn't paying attention. So like, crap happens, shit happens, you know. guess what? I won't do that again. Just like I learned enough on this to where if I was going to make another square, I bet I could do it in half the time, more accurate with less of a headache. And that's really what it comes down to when making stuff. You know, really doesn't matter what it is, experience pays off. And with that said, I just want to share something. One of the things that I learned a long time ago is that really you've only failed if you give up. Now, had I made this, and like the person who had written that post, had I made it and it just was way out and there's no way to fix it, and I just threw it in the round file and just walked away from it, I would have failed. Had I kept going, even if it took 5 of these, kept going and eventually made it, that's not failure, that's success. So really, you only fail completely if you give up. And some of this stuff that you're going to find is going to be hard, and it's not just welding, but in life in general. But as long as you don't give up, you haven't failed. The moment you say, screw it, I'm done, and walk away, that's failure. So with that said, put in the effort, keep welding, keep working on stuff, and thanks for sticking around for the video.